So what are some ways that machines help us move objects? This is a discussion point, but think about it for a second. How have you used a machine already today? Well, you may be thinking about the device you're using to listen to this. If you opened a door, you used a lot of machines. The doorknob, the hinges, the plank, how that door is made. Machines are everywhere and they help us move things all the time. We don't even really think about it anymore. And we're thinking about that. How can we compare using the machine versus not using the machine? That's what this is all about today. So how much easier is that machine going to make my life? Or what do I have to do to the machine for the machine to help me? So we're going to be talking a lot about forces today. Force and distance is the main thing. So the force you apply to the machine is the input force, because you are putting that force into the machine. And then the force the machine applies to the object is the output force. It is putting out that force. And force, as you may remember, is always measured in newtons. Right? If you thought of something, you'd name it after yourself too. So in this picture, our machine is the lever. Right? We got this wood plank and a rock as our fulcrum. The input force is these people here are pushing down on the wood plank. That force is being transferred through this lever machine, and the output force is pushing up on the car. Today we're going to be comparing this input force to output force ratio. So how much easier? Right, this is mechanical advantage. This is the advantage of using the machine. So it is the amount by which a machine can multiply a force. Typically, you want a machine that will multiply it more. Right? That shouldn't be a surprise. It's making your life easier. If we look at this first lever, we have 5 newtons of input force. So if this input is 5 newtons, it'll create 15 newtons of an output force. Okay. It's not bad. That's like if you gave me $5 and I gave you back $15. Or you're not losing, in fact, you're winning. But let's look at this other lever. Right, we've got 5 newtons of input force is going to create 25 newtons of output force. Well, that's better. If you gave me $5 and I gave you $25, that's fantastic. If you had to choose, right, I could either give you $15 or $25. You'd probably take the bigger one. That would have that better advantage, that more multiplication. You may already be thinking about this mathematically. So if you put in 5 newtons to get 15 newtons, by what number are you multiplying 5 by to get 15? Or the reverse way, by divide 15 divided by 5, what number is that? All right. So our formula for mechanical advantage is the force output over force input. Force output in our previous example was 15 newtons divided by 5 newtons, which, as you hopefully knew, is 3. It's just 3. These newtons cancel. It's like 1 divided by 1. and 15 is 3 times bigger than 5. Whether that's $15, meters, kilometers, kilograms, 15 3 times bigger than 5. We don't need any units. Right, so example, if it takes 45 newtons to lift a box, that would have taken you 180 newtons without the pulley, what is the mechanical advantage? So I'm going to leave this one for you, but 45 newtons is what you do. This is your input. And 180 is our output. You'll see output force written in different ways. We'll go through some of the different ways. It can be what it would be without the machine, as it is in this case. Sometimes they call it the weight of the box. So it can be in different ways. Input force, though, is usually the easiest to recognize because it is what you are doing. Okay. So a practice question. This one we'll do together. So a force of 600 newtons is applied to a lever. 600 newtons is applied. The resulting output force is 2,400 newtons. What is the mechanical advantage of the system? Okay, so let's do that. Let's look at that first question. So the force of 600 newtons is our input force. That is the force that they're applying to our little lever. The output force is 2,400 newtons. And I need to find the mechanical advantage. This step here that I already did, don't underestimate the importance of that step. That step is very important. It is going to help you stay organized. And as we start getting more formulas, you know what you have and what you're going to be finding. So make sure you're doing this in your own work as well. So then again, first thing I'm going to do, mechanical advantage. Write my formula. My formula, mechanical advantage equals force output over force input. How much am I getting out of what am I putting in? Right. Also, always write your formula. Force output, put that in, 2,400 newtons divided by my input of 600 newtons. And now, even if I make a mistake in this division, I'm going to get pretty darn close to full marks. And 6 goes into 24 4 times. I get 4. So the mechanical advantage of this lever is 4. It is not 4 newtons. If you said MA equals 4N, you, my friend, are wrong. Units are very important in science when we bring in the math. Units are everything. And mechanical advantage is very specific in that it doesn't have units. It is talking about how much more, right? How many times more is this making your life easier, right? How much more is it multiplying the force? There is no units. We can see that as well with our division. Newtons divided by newtons is 1. They cancel. So there are no units remaining. May help you as well. Draw a little picture. Right, we got a little lever. We're pushing input force, 600 newtons, output force 2400 newtons. Right, our next question. This one is a different, we'll get to. So our next question. A sailor uses a force of 700 newtons to pull on a pulley system. That's the sailor is doing that to raise sails on a boat. The maximum weight of the sails that the sailor can raise with the system is 2,800 newtons. That's the weight. What is the mechanical advantage of the pulley system? All right, let's look at it. All right, our next practice question. So again, this very important step at the beginning, make sure you're doing this. You need to write this down as well on your sheet of paper. This will help you. I can't stress it enough. So, input force 700 newtons, output force 28,000 newtons. Sorry, 2,800 newtons. You notice the output force is often higher than the input force because you want the machine to help, to make it easier, right? A machine that you actually have to put more work in to get something, not very helpful. Although there is a very specific case where that does happen, is okay. We'll get to that. But anyways, here we go. First step, write your formula. To help you stay organized, to help you know your formula too. So mechanical advantage equals force output over force input. Right, now I put it in. So my 2,800 newtons, putting the units in the math is going to help you a lot. My high school science teachers required it. May as well get into the habit now. And your force output, 700 newtons. My newtons will cancel with the division. 7 goes into 28 4 times. So my mechanical advantage is 4. Again, not 4 newtons or 4 anything else. It is just 4. All right, so now let's switch gears a bit and look at speed ratio. So the machine's speed ratio is an important statistic to measure as well. So it's how fast is it going to do this thing. Be careful though, because when we're talking about speed, we actually talk about distance. So speed is the distance an object travels in a specific amount of time. Since the time is the same, going up the ramp or not, pulling on a pulley and the pulley pulling on your object, we use distance. Input distance and output distance. Okay. So, the speed ratio is the distance input over the distance output. You notice that is the reverse of mechanical advantage. So a really quick example, if you have to pull 4 meters of rope through the pulley, if you have to, so that is your input, in order to move a heavy box up by 1 meter, what is the speed ratio? Well, 4 divided by 1, that would give you 4. Right, so let's look at this example. So calculate the mechanical advantage and speed ratio of the pulley system. So we'll do the speed ratio first, and then the mechanical advantage, and see what we notice about the numbers that we get. First thing you're going to do is this, right? You're doing that too. You're writing what you know and what you need to find out. And then the formula. So speed ratio. So speed ratio is distance in divided by distance out, which equals, careful, there's a decimal there, 1 meter divided by 0.5 meters. The meters cancel. If it was easier, you could multiply both by 10 and do 10 divided by 5. You get the same answer. Our speed ratio is 2. Just like mechanical advantage, speed ratio has no units. Our units are canceling. All right, let's look at the mechanical advantage then of this system. Okay, so adding in our force information, let's find mechanical advantage. So mechanical advantage equals our formula, force out over force in. It's always I shouldn't say always, often the bigger number. H equals 10.0 newtons divided by 5.2 newtons. All right, this one you might need to pull out a calculator. So 10 divided by 5.2. You know it'll be reasonably close to 2 as your answer. And it is about 1.9. No newtons, those cancel, just 1.9. So mechanical advantage is 1.9. Very interesting. Notice how similar this is. 1.9 to 2. That is important. And that leads us to our next formula. All right, so don't forget about friction. Whenever we have two things that are moving, we have friction, or even one thing that's moving on something else. Friction will always oppose motion. It's always going against motion. And we need extra force to overcome that friction. That's why things slow down. And that leads us to this comparison. So speed ratio is not affected by friction because we're measuring distances, not forces. Mechanical advantage uses forces, so it is being affected. We have this friction in there that's losing efficiency. So that's why speed ratio represents the ideal mechanical advantage. Ideal meaning if there was no friction, that's what the mechanical advantage would be. And that creates a very interesting dynamic to compare. At our last pulley, we had a speed ratio of 2 and a mechanical advantage of 1.9. So it's losing some force to friction. We want to know how much. And that's where efficiency comes in. So efficiency is a measure of how well a machine uses energy. So all machines will lose some as it operates. Okay, we got heat being lost to friction. We're okay with that, but we need to know how much. So efficiency is always calculated as a percentage. You see in the formula it's got that. That's why at the end we times by 100. It's always a percentage, never a decimal. And it's going to never be more than 100. Right? I can't be 120% efficient. Where's that 20% coming from? You can only do 100%, and even that is very rare. So here's our formula. The mechanical advantage divided by speed ratio times 100. All right, so I'm going to leave this lever question for you, but let's do this formula with our pulley that we just did. And let's take a look. All right, so using the efficiency formula and the pulley system from before, let's calculate its efficiency. So efficiency, write the formula. Efficiency equals mechanical advantage over speed ratio times 100%. So mechanical advantage, 1.9, right? Efficiency would be less than 100. That makes sense. In fact, you cannot have an efficiency of more than 100%. So if you ever get like 112% efficient, you're wrong. Right? You mixed up the numbers. It's a good check to know. Times 100, and it's always going to be a percentage as well. So again, maybe a calculator, 1.9 divided by 2. That'll give you the decimal, 0.95. But don't forget, you got to make that percent. So that's why we're timesing by 100. So this device is 95% efficient. 95% of the energy that you're putting into it, you're getting it out. It's not losing very much to friction. All right, so that's it for today. Remember to write down those steps, what you know, what you need to find. Draw yourself a picture if that will help. And remember, if you do have any questions or you're getting confused with either of these, please ask your teacher. We are here to help you. All right, have a good day. Talk to you later.